All right, here's our video. Solving quadratic equations when, it's part one, when a equals 1. And there's other equations we can do when a does not equal 1, but we'll talk about that in another video. So as you can see in the background there, maybe you can't, there is this kind of little parabola. Let me just draw it, point it out to you, right? See the light in the background over here. And so we're making this line that it's being created, going right through the title into this light, right? Well, that's a parabola. And parabolas are part of quadratic equations, which we'll talk about in the video. But anyway, A, what are we talking about? A. So in a quadratic equation, you'll have, let's say, x squared. We'll write this one, x squared plus 8x plus 12. And here we have a trinomial, and it's set to 0, so we're equaling 0. So the A term is the first term, right? So this will be the A term, and the second term will be the B term. And guess what the C term is? Well, I just told it to you, right? The third term is the C term, right? So that's what I mean by terms. So when A is equal to 1, well, we have a 1 here, 1x. Well, we don't have to put that there because we know any number times 1 is that number, right? So let's get a clean page. Let's solve this quadratic. All right, and we'll do a rough graph of it. So let's say we had what we had before, x squared plus 8x plus 12, and we're setting it to 0. All quadratics are set to 0. So there's a special rule we can do when a equals 1, when the term a, when there's a 1, remember there's a 1 there, but we don't usually write the 1, but a equals 1. So when you see this, the term is what two numbers, I'll write it out, what two numbers when multiplied, will give a product. Product is the answer to multiplication, right? Of C, of the C term. At the same time, they will sum to the B term. Same numbers. Can you think of one? Just put it in here. So we want two numbers that's when you multiply them together, they'll give the product of the C term, which is 12. And when you add them together, they'll get the sum of the B term, which is 8. So we know that's 6 and 2, right? So then we'll make these two binomials. We'll put x plus 6 and x plus 2. So we just factored that trinomial. And if we wanted to check to see if we did it right, we can do something called FOIL, which you should be familiar with. But FOIL is just a way of saying you want to do the first term, the outside term, the inside term, and the last term. You want to multiply them. So here's the first term of the binomial. You want to times it by the first term of the other binomial. X times x is x squared. Then you want to do the outside term, right? X is also the outside term, and you want to multiply it by the outside term of that binomial. And that'll be 2x. X times 2 is 2x. Then you want to do the inside term, 6 times x. That'll be 6x. Right? And then the last term, which is 6, of that binomial times the last term here. And that'll be 12. Don't forget to combine like terms, and we have x squared plus 8x plus 12. So we know we did it right. We did FOIL to make sure we did it right. But now moving on with this, we know, let's bring back the two binomials we made, x plus 6 and x plus 2. Rewind the tape if it's too fast for you here. And we want to now know the roots. They're called the roots, or they're called the zeros. You'll hear it two ways, the roots or the zeros. And we can make a rough graph of our parabola. Here's the coordinate plane. So basically, whatever you're seeing, whatever operation you're seeing, just do the opposite and you can get the roots or the zeros. But again, they're all set to 0. So if you do x plus 6 equals 0, if you minus the 6 on both sides, you get x equals negative 6. and the same for the other side. So we know that the roots are -2, there's one root, or 0, and -6, 3, 4, 5, 6. So now we have where the roots are, or the zeros of our parabola, for x squared plus 8x plus 12. But now we're trying to find, where does this parabola go? Where is the vertex? The vertex. In other words, the vertex is where the parabola will go down or go up, and then it will reach its peak. It'll either reach its minimum peak or its maximum peak, and I'll talk about that. So to find this out, we need to know the axis of symmetry. The axis of symmetry is basically where the parabola is cut in half, and that'll be the middle number. Now, sometimes you can judge it. You can see where is the middle. Now, if you look at these, remember we had 6. We'll put a little 6 over here. -6 over here, and -2. Well, you can see that in the middle is -4, right? The middle is -4. So we know that is the axis of symmetry, cut in half. Now, if you didn't know that, there's something you can do here too. You can do this formula, -b over 2a. It's a formula that you should remember, and you'll see it again and again. What do I mean by -b? Well, again, remember the 8 over here was the b term. So we're going to say -8 over 2. And the a term, remember, this is a 1. So we just say 2, and you'll get -4, like we judged before. I know it seems like a lot here, but we'll do another one. We'll do actually 2 more so you can get used to it. So we now know that the axis of symmetry is -4. That'll be the x term. We need to know the y term to find the vertex. Remember, the vertex is the x and the y. We can plug in -4 into our equation. Let's change the color so it doesn't get too blurry here. So our original equation was x squared. So we're going to say, and put parentheses, -4 squared plus 8 times -4 plus 12, and we'll get the y term. Well, -4 squared is 16, and 8 times -4 is -32 plus 12. So we're going to have 16 minus 32, which is -16, plus 12, and it gives us -4. So now we know the vertex. The vertex will be -4, -4. 1, 2, 3, 4. That's where the vertex is. So our parabola, our rough graph of our parabola, is right there. And it's going down. So as I said, the vertex is where as it's going down, it stops and goes up. That's a minimum, what they call a min or a minimum. So that's where our vertex is. And when you see it going up like that, that's like a smiley face. It's positive. That's a lot. So let's do another one and go back if you need to. I'll pause for a few seconds. All right, let's do another one. And I'll write slower. Let's say we had x squared plus 10 plus 10x equals -21. This looks a little different. Doesn't look like we did before, right? Remember, we want quadratics to be set to 0, so we want that 21 out of there. Right, so we're going to say x squared plus 10x plus 21 equals 0, right? We just add the 21 on both sides, and now we have what we want. So remember the rule, what two numbers in the c term, if we multiply them, we'll get a product of 21. And at the same time, we can get the sum of the b term, which is 10. What do you think? Well, 7 times 3 is 21, right? That works. And 7 plus 3 is 10. So we can use x plus 7 and x plus 3. And by the way, it doesn't matter where you could put the 3 first, x plus 3, x plus 7, doesn't matter. And if we did FOIL, we would get that answer. So if we want to just do it real quickly, remember x times x, FOIL, first times first is x squared. The outside term times the outside term, that'll be 3x. The inside term times the inside term, that'll be 7x. Right, and the last term times the last term, give us 21, which is x squared plus 10x plus 21. So we know that. Let's put a box here. Change the color. Choose that color. Why not? So we said that we have x plus 7 and x plus 3, and we're trying to find the roots or the zeros, and we know they're the opposite of the operation we're seeing. So if we make a rough graph, we know one of the roots will be -3, and another one will be -7. So let's see, we have 3, 4, 5, 6, 7. Now we're trying to find the axis of symmetry. What's the middle number? What do you think the middle number is? Well, you can eyeball it, or if you didn't know, you can do that formula, which you should keep in your head, -b over 2a. The b term is 10, so it's going to be -10 over 2, which is -5. So -5, right there, is our axis of symmetry. We already know the x term is -5 for our vertex. We just don't know what the y term is. We're trying to find the vertex. So what do? We take the axis of symmetry, plug it into the formula. It's going to be -5 squared. Don't forget, if you're doing this on the calculator, put those parentheses in. And then we're doing plus 10 times -5, and then plus 21. So here we're going to have 25 minus 50 plus 21. We're going to have -25 plus 21, and we're going to have -4. So the vertex is right there. And this is just a rough draft, and we're making our parabola. And again, it's a positive parabola because it's a smiley face. Now, you can do this on the calculator also. You can just plug in the equation and press graph, and you can see the nice graph. Let's do one more. Let's do a -1 now this time. All right. So let's say we had -x squared plus 3x equals 2. Why don't you try to do this on your own? Pause the tape if you wish. Remember, we want quadratic set to 0. So the first thing I'm going to do is I'm going to put -x squared plus 3x, and then we'll say -2 equals 0. So pause if you need to, if you want to. Now, we want to factor out that negative. Get that negative out of there for a while. So we'll just say -1 because we know it's just negative. You don't have to put the 1 if you don't want to. And then we can factor out. So this will be x squared, because if I distribute the -1 back in, I'll get -x squared. Right? And then I'll have a -3x because I'm trying to get a positive. A negative times a negative is a positive if I distribute it. And of course, it'll be +2. So then I get this. Now, let's just concentrate on what's in the parentheses. Let's see if we can make two binomials. What two numbers will multiply to 2, give us a product of 2 in the C term, but in the B term, we can get -3. What do you think? I'll make the binomials. Put our x's in because we know we're going to get x squared. Well, if we did -2 times -1, that will give us +2, right? And -2 plus -1 is -3, so it's going to be x minus 2 and x minus 1. And we'll make our rough graph. So we now know the roots are 1 and 2. It's right there. So we know, again, we know what the roots are, but we're trying to find the axis of symmetry. What is the axis of symmetry? So we can find our vertex. What do you think it is? What do we do? We can do the form. Well, you can clearly see that the middle term will be 1.5. We can clearly see that, right? But if we didn't know, you should know the formula by now. -b over 2a, right? So now that we know it's 1.5, let's take the original equation we had. We're going to have negative x squared, so it's going to be negative 1.5 squared without parentheses. So we want to do 1.5 squared, and then whatever the answer is, it'll be negative because we have a negative right there. We got to be careful. And then we're going to have plus 3 times negative 1 plus 1.5. Be careful. That's only negative 1.5 because we had the negative there. And then we have our minus 2. So if we do all that, we're going to have negative 2.25. Just do this on the calculator if you wish. Plus 4.5 minus 2. And our vertex, well, we know our vertex is negative, is 1.5. 1.5 right there. And the vertex will be 0.25, or we can just say a quarter, whatever you wish. So if that was 1, we can say it's about there. And it's going down. Now we have a maximum on top, a maximum vertex, or just a max. And since it's going down, it's making a frown, it's a negative parabola. All right, so those are 3 examples we did on quadratics when x equals 1. And we'll have other videos now when x is greater than 1. All right, that's it today.